Okay, good afternoon again. For the next 2 days, 2 to 3 sessions, including the extra session, we're going to talk about regression. Okay, the objective of doing a linear regression, a model of regression, is to be able to explain the variable of your choice. So you're specifically looking at a particular variable and you'd like to explain that variable, describe that variable in relation to how it is influenced or how it is affected by other variables. There are certain assumptions that we make when we do a regression, and it's written here, guys, in your notes, regression assumptions. So number one, linearity of the data. So if you're for example, trying to explain hourly wage, which we're going to look at in a while, hourly wage with respect, its relationship with education. So you have data, hourly wage, and you have education, and you'd like to see if there is a relationship between them. There's a linear relationship between them. To create a model with these two variables using linear regression, there has to be, of course, a linearity as far as the relationship between the two variables is concerned. Kasi kunyari plinat natin, nag-create tayo ng scatter plot. Sabihin natin si education sa x-axis, sa y-axis si hourly wage. Okay, we're taking a look at those two variables. Tapos lumalabas na ang relationship nila is quadratic. So it doesn't make sense, guys, to model the relationship of the two variables using linear regression. Dapat yun, quadratic regression. So ang assumption natin dito, yung x variable, which we will call the predictor variable, explanatory variable, and the outcome variable or response variable, aka dependent variable, should be linear. So pag prinat natin sila, dapat merong sense ng linearity dun sa relationships nila. Okay, second, dapat yung linearity, guys, ng parameters, when we estimate the parameters, yung mga beta coefficients natin, they should be linear. Okay, I'll explain this as we go along. Third, so nagka-model tayo, we were able to one of the main reason why we conduct linear regression is because we would like to predict the response variable, the outcome variable, or the dependent variable, making use of your independent variable or variables. So pag predict natin, guys, pag nag-create tayo ng model, tapos we're creating a in order to predict our response variable or outcome variable y, yung model natin hindi magiging perfect. So may mga points tayo dun sa model natin na hindi tumatama yung actual value natin. So there's what we call residuals. Meron tayong error terms. So yung error terms na yan, guys, pag plinat natin yan, dapat constant siya, constant yung variance. Ibig sabihin, it should not increase, it should not be increasing, or it should not be decreasing, or it should not display a particular pattern. Dapat random lang siya na ang gulo-gulo na walang pattern, tapos dapat constant lang siya, no? Over the range of the values of your dependent variable, no? So ang tawag natin dun sa situation na constant yung variance ng residuals natin, that's what we call homoscedastic, no? Homoscedasticity. Ang opposite niyan, guys, yung heteroscedasticity. Okay, where we find that your error terms are display a pattern, no? May pattern siya, kunyari tumataas siya. May trend siya na pataas o may trend siya na pababa, or it displays a curve, no? May curve na yung shape yung ng residuals. So in that case, heteroscedastic yung variance natin, yung errors natin, yung residuals natin, and that's violative of the principles or assumptions of classical linear regression model. Okay, tapos number 4, dapat yung explanatory variables natin, yung independent variables natin, dapat hindi sila collinear. Ibig sabihin, dapat hindi strong yung relationship nila. Kasi, kunyari, perfectly collinear yung dalawang independent variables. What will practically happen is that mag-aagawan sila sa pag-describe kay dependent variable. So much so that it will be very difficult kung to explain kung sino yung nag-explain kanino. So that's what we mean by multicollinearity. Now, we don't want the explanatory variables to be collinear. Rather, we want the dependent variable and the independent variables to be strongly correlated. Gusto natin si dependent variable correlated kay independent variable. Hindi natin gusto na hindi sila correlated. Kasi kung hindi sila correlated, hindi natin magagamit si independent variable to try to predict or to explain your dependent variable. Kasi wala silang correlation. Okay? And then number 5, guys, yung residuals natin, yung residual error terms natin, dapat hindi rin sila correlated. This happens more if it's a time series. Kasi pag time series, di ba sabi natin, may structural arrangement yung data. Hindi natin siyang pwedeng rearrange. No? Unlike a cross-sectional series na pwede natin ipagbalik-baliktad yung data, it doesn't matter. Okay? Kasi wala namang arrangement, wala namang structural arrangement yung data natin kapag time series. So normally, kapag this independence of residuals, it's applicable to time series and not to cross-sectional data. Number 6, normality of residuals. Dapat yung error terms natin, dapat normally distributed. Pag hindi siya normally distributed, we might have problems with our with our model, no? With our predictions. So all of this, guys, we're going to look at one by one as we go on. Now, ang mga packages na gagamitin natin for linear regression, okay, some of this we have met, yung psych, PaceText, OLSRR, this will be used for stepwise regression. Stargazer for coming up with reports, okay, in a nice way. So may pinost din ako, guys, ito nice output R and Stargazer. These are documentation for Stargazer. No? So magagamit nyo to especially pag nag-generate kayo ng report. No? And then performance analytics, this is a very powerful package. We'll have more of this this coming Friday when we look at packages that help us in accessing data and manipulating financial data. Okay, so I hope you have already imported our data set, wage. Let's try to take a look at this first. Tingnan natin yung wage natin. So our data set consists of 8 variables of 526 observations. This is actual data, US data to. I just forget kung anong year to, 1980s yata to no? Sorry, nakalimutan ko. And then these are the variables. Education referred to the number of years a person has. Experience is the number of years in work. Tenure is the number of years in that specific work and that person was engaged in at that time of the survey. Race, okay, so pwede siyang dalawang levels, white at saka non-white. So si race, white at saka non-white. Gender naman, female at saka male, no? Okay, that's a gender. And then here, civil status, single or married, no? And the number of dependents, kung ilan yung anak, tapos hourly wage per hour na wage dun sa company. So we have 1, 2, 3, 4, 5 variables that are quantitative. 3 are categorical. Okay, 3 categorical, 5 quantitative. So dito, ang gusto nating malaman, ang gusto nating ma-describe or i-model si hourly wage. So we'll first start with simple regression. Ibig sabihin, isa lang dito ang gagamitin natin, si education initially, to try to describe hourly wage. Tapos tingnan natin kung mag-i-improve pa yung model natin, kung gagamitin din natin sila, experience, tenure, etc., even the categorical variables, kung magagamit din natin na para i-describe, para predictors on hourly wage. So again, guys, linear regression tells us of the relationship between the variables. Now, it does not tell us that, it does not tell us of causation, C-A-U-S-A-T-I-O-N. Hindi natin sinasabi sa regression ng si education causes hourly wage. Okay? It's more that education influences hourly wage, but not really causes. Or education is related to hourly wage. Okay? Experience is related to hourly wage, etc. So in regression, guys, we're not talking of causation. We're not saying that education causes hourly wage, but rather education influences or education is related to hourly wage. Okay, so let's go here, guys. Let's na-view na natin, no? Na-view na natin si wage. Names, guys, will tell us ano ba yung mga variables niya. Ito. So alam na natin yan. Education, or experience, etc. By the way, kanina sabi natin may mga categorical dito, no? Yan, single, married. Ang question, nagagamit ba natin yan in regression to try to explain hourly wage? Yes. Sa regression kasi pwedeng quantitative at saka pwedeng categorical variable ang ginagamit natin sa pag-explain ng dependent variable natin. Yung dependent variable natin, guys, dapat continuous variable, dapat quantitative yan. Okay? Tapos hindi rin dapat hindi siya hindi siya binary, no? Dapat continuous variable. Yun ang rule natin sa regression, sa linear regression. Okay, so these are the names of the variables. Let's dispense with head and tail, wage, brackets lang naman yan. Tapos structure. Okay, so ito ini-explain lang kung ano yung laman ng wage data set natin. Integer, si education, experience, tenure, race, gender, civil status. These are categorical variables. Particularly factors, no? Pwede silang magamit na factors. And then number of dependents and hourly wage, which is the variable of interest. Ito yung gusto nating ma-predict or ma-model. Okay? And then we can use the summary function. Sa summary function, okay, yung mga quantitative variables, kino-compute yung first quartile, second quartile, third quartile, etc. Minimum, maximum, and then the mean. Tapos yung mga character variables, yung mga categorical variables, just the count, no? Kung ilan lang sila. Okay. Now, it's important kasi ang mangyayari, guys, finals natin next week. Tapos ang ang part 1 ng finals online, part 2 will be group and it will be about regression. Tapos, so expected, simula, syempre, sa data nyo, titignan nyo muna, explain nyo yung data nyo, and you have to make use of what we call descriptive statistics. Anong descriptive statistics? Explain nyo yung discuss yung mean, median mode nila, yung quartiles. You can use here also ggplot, no? But yung sa, for example, we can make use of the psych package to generate yung descriptive statistics ni wage. Okay, so si psych package through the describe function, it gives us yung mga variables andi dito sa rows, and then yung mga naka-asterisk dito, it means that these are characters, the rest are quantitative. So kino-compute yung mean, standard deviation, median, mean absolute deviation, minimum, maximum, skewness and kurtosis, importante yan, guys, no? So you have to explain also in your paper kung ano yung nature ng variable, describe the variable in terms of this. Of course, guys, yung mga numeric, yung mga quantitative, yung mga categorical variables, walang meaning tong mga to, no? No meaning yung mga measures na yan. Okay. So aside from that, pwede din natin gamitin si package na paste text. You can have here stat that describe yung wage. Ang kaibahan lang nito, yung variables nito, andi dito sa column. Unlike si kanina si describe, baliktad siya. Okay, so we can see here also several measures. Okay, andyan si max, minimum, okay? Median, mean, standard error of the mean. Then we have the confidence interval, variation, standard deviation, coefficient of variation. Okay, so you have here several descriptive statistics. We're not going to go into this kasi guys, ang assumption natin yan na nakuha nyo nandun sa previous stat subject nyo. Okay, so also, meron din tayong, itong Stargazer guys, maganda to kasi ito yung pinost ko na material din na you may look at kasi it gives us a very nice, okay, very nice output. Meron pang iba nito mamaya. Okay, so take a look at this, no? Ito yung, notice ang linagay lang niya yung mga quantitative. So you have the count, mean, standard deviation. Okay, so it's arranged in a good way compared to the others. No? And then you can make also you can make use of also of scheme. Okay, scheme ganun din, parang tabular siya. Okay, dito kay scheme naka-divide yung categorical tsaka yung quantitative. No? Okay, so ito categorical character. Okay, we don't have much information from that. Tapos ito yung numeric. No? So andyan dyan yung mean, standard deviation, minimum value, first quartile, second quartile, third quartile, maximum value, and then a picture of the small picture of the histogram. Okay, so there are a lot of packages of functions that you can use in order to describe your data. Okay, so now we go to performing the simple linear regression. So of course, sabi ko nga, bago kayo mag-regression, i-describe nyo muna yung mga data nyo, no? Ano yung mga variables nyo. So take a look at that using descriptive statistics. Explain nyo. So what we're going to discuss is we're going to model si hourly wage that will be our response variable, our dependent variable. Okay, and then una, ang gagamitin muna natin si education. So pag iisa lang yung predictor, isa lang yung independent variable, then we call it simple linear regression. Okay, so ang mga independent variable, it can be quantitative, it can be categorical. Pero si dependent variable, in order for us to perform regression, kailangan quantitative siya, kailangan continuous siya, no? Continuous data. Okay, so first guys, i-plot natin, no? So ito pwede ba natin tumaplat? Paki-plot nga yung unang line guys, ito. Plot, edu, hourly wage, and then paki-chat kung ano nakita nyo, ano nangyari. Na-plot nyo ba siya? Scatter plot. Kindly chat please if you were able to plot it. Okay, thank you. Education not found. Bakit? Kasi guys, if you take a look at our environment, yung object natin wage lang. Si wage yung data frame natin. Yan yung data natin. Si education at saka si hourly wage, it's just a variable in your wage, di ba? Yan siya, no? So hindi yan mare-recognize ni R. So kailangan natin, guys, so we go here, sa pangalawa, kailangan i-define natin. So wage, education, wage, hourly wage. Then we can, of course, include label ng X, label ng Y, plot character natin. Notice we're using the plot function. This comes from base R, no? Okay, plot 20, yung maliit na circle to, frame, walang frame, false, then main. No? Okay, so let's run this. Highlight natin, run. Okay, so we see here our scatter plot. So ito yung scatter plot natin. Okay, kaso nga lang, yung default niya, yung years of the education, hanggang dito lang, no? Si hourly wage okay lang kasi kuha naman niya lahat. So what we can do is we can modify this by adding axis. Okay, so tingnan nyo to guys, no? Dito, kinopya lang natin yung unang, yung to, this first three parts, and then we added axis. Axis, so we're modifying axis 1, will refer to x-axis. Kung 2 yan, y-axis. Yan, if it's y-axis, use 2. Yung minomodify natin. And then sequence, we're defining from 0 to 20, dapat yung ano natin, yung yung x-axis, increments of 5. So let's run this. Second one. Okay, so yan, at least nagkaroon tayo ng improvement hanggang dito. Okay? So let's take a look at the relationship between hourly wage and education. Usually guys, yung independent variable, siya yung linalagay sa x-axis. Yung dependent variable ang linalagay sa y-axis. Okay, what do you think? May ano ba? May relationship ba sa kanila? Is it a positive relationship or a negative relationship? Kindly chat guys, kung positive relationship or negative relationship. Or kung meron man, no? Meron bang relationship? Positive. Okay, thank you Mauro. Okay. The rest, ano nyo? Okay, weak positive. Thank you James. Okay. So you're both correct guys. Positive siya. We can categorize it as weak kasi okay, pag mukhang ito yung line ito yung regression, ito yung line na nagbe-best describe sa kanila, pero mukhang mababa yung slope. Kasi medyo scattered yung data eh. Malaki yung ano niya, yung range, no? So for a person who has dito sa baba medyo mukhang walang relationship, no? Kasi hindi mo na determine dito yung regardless of the years of education, mukhang pare-pareho lang na mababa yung wage, no? Dito medyo nagkaroon na dito, no? Habang tumataas yung education, mukhang tumataas naman yung tumataas yung hourly wage. So you find here a positive relationship, albeit it's quite weak. It's a weak positive relationship. Okay. Now, what we can do here is idagdag natin guys yung average ni hourly wage at saka average ni education. Isama natin dun sa plot natin, no? So this one, aside from the first 4 lines, pinasok natin si AB line, H is horizontal. Ibig sabihin, horizontal ng mean ng hourly wage. Tapos linagyan natin yung color, tapos yung width niya, at saka yung line type, which is 1. And then also here, vertical line for the mean of education. So let's run this. And then we can see here that, okay. So this is the mean of education, our education. And this is the mean of hourly wage. So mga 5.9 yata tong mean na to, no? Okay, so dito makikita natin guys na si average ng hourly wage is around 5 point something. Si ano naman, mga 12, 13, thereabouts, no? Okay, so babalikan natin tong plot na tumamaya kasi may i-discuss tayo dito. Alright, so let's move on. Okay, binanggit natin kanina yung correlation. Aside from plotting guys, we can also compute for correlation. Okay. Without running the first chunk, can we run this, guys? Correlation, education, and hourly wage. Let's try to run this. Run natin. Ganun pa rin, nag-error pa rin. Ano? Kasi hindi niya alam kung sino si education at saka si hourly wage. And we know we were able to answer that already. We know that this came from the wage data set. So in order for us to compute for the correlation, pwede natin ilagay dito wage, dollar, education, wage, dollar, hourly wage. But is there another way? Yes. We can use this function attach. No? Ang ibig sabihin nitong attach, then the data set, ibig sabihin lahat ng mga variables dito will refer to wage. Okay? It is efficient in a sense kung iisa lang yung data set na ginagamit natin, yung wage. Pero kung maraming data set tayong ginagamit, tapos pabalik-balik tayo dun sa ibang data sets, then it's not good to do that. No? Hindi maganda na i-attach pa yung wage. Gamitin lang natin yung usual, yung data set, then dollar, para alam natin kung saan nanggagaling yung variable na yon. Okay? So we can do this. So let's try to do this. Attach wage. So na-attach natin si wage. We can now compute for correlation. And it's 0.41. Okay? So medyo weak, no? Weak yung correlation kasi yung strong mga 90 plus 70 plus medyo very strong 90 plus, siguro 70 plus strong. Moderate, tapos may moderately strong pa, tapos may moderately weak, tapos very weak. No? Maybe itong 0.41, maybe moderately weak. Iba-iba kasi yung pag-classify nila. No? Okay, so ito guys, ito naman. Yung wage, di ba maraming ano yan, maraming variables. Can we get the correlation matrix of all the variables? Let's try this. Okay, ano nangyari guys? What happened? Were we able to get the correlation matrix of the dataset wage? Hindi, di ba? Bakit hindi? Kasi may mga categorical variable dun. You cannot get the correlation of a quantitative with a categorical with a categorical. Hindi natin pwedeng kunin yung correlation nun. So what we can do is, we can subset that. So correlation wage, lahat ng rows to, di ba? Comma. And tanggalin lang natin si negative C, 4 to 6 means we're removing columns 4 to 6. Okay, if you recall guys, di ba yung bracket natin, row, column. Okay, so let's run this. And then we have our correlation matrix. Yan. So tinanggal natin yung mga categorical variables. Okay, and since this is a correlation matrix, the diagonal will be 1. It means the variable is a perfect correlation with itself. No? Nandito makikita natin, okay? For example, ayaw natin guys yung mga independent variables natin or response variables natin, ayaw natin na highly correlated siya with the others. No? For example, itong sa tenure. 0.49, 0.5. Medyo ito yung pinakamataas, no? Among the among the independent variables. 0.49 with experience. So hindi naman siya talagang strongly correlated, but I think this is the highest among the correlations between the independent variables. So possibly, baka magkaroon tayo ng problema dyan. No? Kasi ayaw natin na yung independent variables natin are highly correlated with other independent variables. Okay. Tapos ito, guys, gusto natin si dependent variable highly correlated with the independent variables. So ito 0.40, that's okay. So si education ang may pinakamataas na correlation with hourly wage. Of course, ito 1 kasi with itself yan. Okay, so that's why we're using education first as our first variable to try to describe hourly wage using simple regression. Okay, there's another good way to, okay, nagkaroon ako ng math processing error. Okay, anyway. Okay, there's a good correlation chart making use of the performance analytics. No? So ito guys, again, the first one will not work kasi okay, kasi sa wage guys, may mga mali ito, no? 4 up to 6. Meron tayong mga characters, yung 4 to 6. So dapat we can make use of this, pero dapat tatanggalin din natin sa wage dataset yung mga categorical variables. So let's run this. Okay, so this is a good way to present your correlation. Let me just okay. So you have here sa lower bottom, you have here the scatter plot between the variables, and then you have a geom smooth line here. And then in the diagonal, you have the histogram of the variable itself. And then here on top, you have the measure of the correlation. And then you have asterisk here, which means yung statistical significance ng measure na to, ng correlation. Okay, so let's take a look at this very quickly. So education and experience, makikita natin na medyo, okay, education with experience. Okay, negative 0.3 yung ano nila, yung correlation, that's why pababa, no? Okay, pababa yung relationship nila, no? Ibig sabihin, habang tumataas yung isang variable bumababa. So actually, it doesn't make sense naman, no? So kapag tumataas ba yung education, tumataas din yung experience. Okay? So some variables, guys, walang sense yung ano nila, no? Yung correlation nila. Magagamit lang yan, of course, dun sa pag ginamit natin siya as both factors or both predictors. Yung strength nitong 0.3. Okay, the 3 stars here means this is significant at 0.001, no? Or at 0.1% level of significance. Okay, so highly significant siya, tapos negative siya. Ibig sabihin, negative na weak correlation between education and experience. Okay, ito yung minention natin kanina, si 0.5. So it's between, so how do you determine this, guys? Tingnan nyo lang kung ano yung nasa, ano niya, nasa variable to the left and variable below. So this is experience and tenure. Sinabi natin to kanina na high correlation, moderately high, no? Or maybe between experience and tenure. Okay, the rest, itong si tenure at saka si education. Okay, so 0.056, notice na maliit din yung pagkalagay ng number, ano? Unlike this one na malaki yung correlation. And this is not even statistically significant, no? Kaya titingnan nyo, guys, yung plot ni tenure at saka education ito, no? Halos vertical line, horizontal line. Walang correlation. Okay? All right. Then, ano pa? So the rest here, same explanation. Si hourly wage, gusto natin matataas yung correlation ito. No? Like this, education, 0.41. 3 stars, ibig sabihin statistically significant at 0.001 or at 0.1%. Also this, 3 stars din, statistically significant. Ito, 0.11, 2 stars lang, statistically significant at 1%. Kaya mas maliit yung font niya, 0.11. Ito, maliit lang, negative, tapos hindi pa statistically significant. So, malamang, guys, ito, number of dependents is not a predictor of hourly wage. Hindi siya correlated. No? So, dito pala makikita natin, guys, kung ang isang independent variable possibly will be a candidate for a predictor or not. From the figures here, makikita natin sa malamang si number of dependents, baka hindi to significant predictor ni hourly wage. Si education, malamang, no? Si tenure, malamang. Ito we can't say, no? Pero we have a significant naman yung correlation nila, pero 0.11, very weak, no? It remains to be seen kung magiging significant predictor si experience ng hourly wage. We will have to conduct now our regression model. Okay, any questions dito, guys? Any questions sa plot natin? Paki-chat nga, please, kung clear so far. Clear ba, guys? Ano natin? Okay, thank you. Dalawa pa lang, the rest? Okay, thank you. Good. All right, so let's go back to our model. Ito din, guys, you can use the correlation plot to describe kung ano yung mga variables na mataas yung correlation with your dependent variable hourly wage. Okay, so now, ito. So this is now, we're going now to create our regression. We'll create an object called model1, and then the function is LM. Linear model, and then you first identify your dependent variable, hourly wage, and then tilde, education. This is our predictor. This is our independent variable. And then identify natin kung ano yung data, kung saan galing yan. No? So let's run this. Okay. And then kasi linagyan ko ng parenthesis dun sa harap, no? Ibig sabihin mag-generate siya ng output. So intercept is 0.9049, negative 0.9049, and then education is 0.5414. Okay? So ibig sabihin, yung influence ni education is 0.5414. For every 1 year increase in education, there's a corresponding $0.54 increase in your hourly wage. Yan ang ibig sabihin yan, no? Okay, let's discuss continue discussing. Dali, baka may question? LM means linear model. Okay? LM is a function, no? Okay, in fact, 'di ba, pag function yan, pwede nating ano yan, LM, no? Linear model. Okay, you can seek the assistance of the help. So that's from the stats package, which comes with R. Pag binuksan natin si R, kasama na siya. Kaya nga hindi na natin ini-install yung linear library yan, no? Okay, so LM is used to fit linear models, can be used to carry out regression, simple single stratum analysis, etc. So there are other, okay, may mga information pa tayo dito, details, and then you have some, okay, may examples ba dito? Okay, walang example. Okay, so going back, guys. So LM is used for linear regression, no? Okay, now, para makuha natin yung buong resulta, we can make use of this summary model 1. Run natin to. Okay. So here we can see the full report. This is the full report of your regression model. Una, sinabi niya, rin-recall niya yung formula na ginamit natin, LM, hourly wage regress on education data is equal to wage. Residuals natin, ito yung error terms natin, no? And then we have this coefficients. Coefficients, you have the intercept and then the education. Okay, bakit may intercept at saka may education? Because, guys, we're modeling. Nagmo-model tayo dito, no? Minomodel natin dito si hourly wage. Okay? And sa line, guys, di ba, sa line ang equation y is equal to mx plus b, di ba? If you recall, guys, ito yung equation of a line natin. Ito yung dependent variable, m is the slope, x is your independent variable, b is your intercept, no? Or sa ang ginagamit natin usually diyan, b null plus b1 times your x, and then you have plus an error term, no? So ito talaga yung complete na formula. So our y is hourly wage. So dapat yung natin, okay, this is actually equal to hourly wage is equal to beta null plus, yung beta null natin is, di ba ito? Negative 9.09. Ay, ito. And so this is our intercept, negative 9, negative 0.9. Round ko na lang. 905 plus 0.54. Okay, yun na lang, no? Times education plus a certain error term. So that's our model, guys. Hourly wage is equal to the intercept plus the slope times your independent variable times plus an error term. So we can interpret and we can predict now hourly wage. Pwede na natin ma-predict si hourly wage kasi, okay, kasi may equation na tayo, may model na tayo. So let's first try to explain what these are. Ano ibig sabihin ng negative 9.0485? Okay, if you recall from your algebra, the intercept is the value of your y when all the x's are 0. So in a nutshell, well, ang ibig sabihin nun, ang hourly wage daw natin, negative 0.9 if education is equal to 0. So kung education is equal to 0, papalitan natin ng 0 to, magiging 0 na itong term na to. So ang mangyayari lang, ang matitira, negative 0.9 lang. No? Negative 0.9. So this is the value of your hourly wage is a person does not have any education at all. Of course, wala siyang meaning, guys. Ano? Wala siyang ibig sabihin kasi pwede bang magkaroon ng negative 9 na hourly wage? Ibig sabihin ba, ikaw pa nagbabayad sa company, nagtatrabaho ka sa company, tapos ikaw pa nagbabayad sa kanila? Okay, so that doesn't make sense, no? So mali yun. And then also, take note, may probability siya dito. No? Okay, what's the probability? 0.187. Okay, may rule tayo na susundin. Okay. Nag-error tong ano ko. No? I'll close this first. Okay. Okay. As regards p-value, no? P-value, ang usual na level of significance, is equal to ilan, guys? 0.05, di ba? So what we're going to do is to compare the probability, the p, this p, with 0.05. Okay, and then the general rule is when the p is low, the null must go. Okay, so remember that, guys. When the p is low, the null must go. Pag sinabi nating low, of course, may benchmark yan, yung level of significance na ginagamit natin. Usually 0.05. Okay, in other fields, it might be 0.10. Sa iba, sa mas stricto, mas mataas yung level of significance. Okay? So, let's now start with the null hypothesis of this. So, may null hypothesis na sinasagot dyan. So, for intercept, B0 kasi siya is equal to 0. Okay? Tapos yung isa naman, I'll call this HO2, HO1. Okay, then B1 is equal to 0. Okay, let's answer this question. Notice, guys, medyo I'm going through this kasi these have been discussed in your prior statistics subject. So we can now create an inference. Itong intercept natin, okay, statistically significant ba itong negative 0.9 na yan? Or baka nagkataon lang yan, baka statistically insignificant yan. Ibig sabihin, there's a probability that that value is 0. And that's what we're testing. No? Ang null hypothesis natin, B null is equal to 0. And since P is, so ang conclusion natin dito, we what? We reject, okay, the null hypothesis that B null is equal to 0. 0, since the p-value is equal to 0.187 is greater than 0.05. Okay? 0.05. Mas mataas siya kaysa kay 0.05, no? So, there is strong statistical reason to believe that beta null is equal to 0. Okay, so possible na si beta null, ito intercept, possible na 0 yan. Okay, the probability that yung 0.187 natin way exceeds yung level of significance natin. Okay, how about this, education? Ang education, ang B1 natin, ang estimate natin 0.413, 0.54, no? And dito yung standard error niya, and dito yung t-value, and then yung probability. The probability is, ano yung probability ni education? That's 0. Ilang zeros yan? To the negative 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No? And then 2. Okay, so mga ganyan yung value niyan. 2 e to the negative 16 or 2 times 10 to the negative 16. So this is way, 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 way lower than 0.05. Okay, so anong conclusion natin? Diba? When the P is low, the null must go. Right? So anong conclusion natin? we fail to reject or we reject? Ay, sorry. Mali ako dito. Sorry we fail to reject. Okay, hindi natin pwede i-reject to. Pag sinabi natin hindi natin ma-reject, so possibly B sub O is equal to 0. No? So there's strong statistical reason to believe that beta null is equal to 0. Si second hypothesis naman natin, si B1 is equal to 0. Anong conclusion natin? We what? Pakichat nga guys. We what? We reject, correct. Tama, no? We reject the null hypothesis, etc. No? Sundin lang natin yung ano. We reject the null hypothesis that that B sub 0 is equal to 0. Okay, correct. Thank you. Reject natin yun. No? So ibig sabihin, there's strong statistical reason to believe that this is not true. B1 is not that B1 is equal to 0. So possibly B1 is not equal to 0. So that's our kaya nga natin reject, no? Okay. All right. So ito guys, nyo, tatlong stars as I mentioned a while ago, it's significant at 0.1%, 0.001. Pag dalawang stars makikita nyo, significant at 1%. Pag isang star, significant at 5%. Pag dot lang, significant at 10%. So, yun yung ano ni R, no? Yun ang ginagawa niya. Pero sa iba pareho din, halos pareho din. Yung iba naman, medyo iba. So, but generally, ito yung magsasabi sa atin kung significant siya. This is not significant, wala siyang asterisk. This is significant, tatlong asterisk, significant at 0.001 or 0.1%. Okay, next. Standard error, okay. 3.378 on 524 degrees of freedom. Saka na natin tingnan to, no? Ito titingnan natin, okay. Multiple R squared, 16.48%. Adjusted R squared, 16.32%. Okay, ano ibig sabihin nitong multiple R squared? Multiple R squared, that's your R squared. So napapansin nyo guys, dalawang klaseng R squared natin, ano? The ordinary R squared at saka the adjusted R squared. I'll explain kung ano yung kaibahan nila, no? So your R squared, guys, is also called your coefficient of determination. Yan tawag niya, no? Coefficient of determination. And what does that do? Okay? The coefficient of determination tells us of the proportion of the variability of the dependent variable. In this case, what's our dependent variable? Hourly wage, okay? That can be explained by the independent variable. And that's your education. Okay. So yan yun, ano? Yan yun. Coefficient of determination. Ibig sabihin, yung variability ni hourly wage, 16.48% of that can be explained by education. So ang kaya lang niya explain ng model natin, where we used education, is 16.48%. Ibig sabihin, guys, nun, 83.56% ang hindi kayang i-explain ng model natin. So, sino pwede maka-explain ng 83.56%, 52% na yun? Malamang other independent variables. Baka kayang madagdagan yung coefficient of determination or yung R squared natin if we add more independent variables. However, guys, may caveat dun, no? Kasi baka ma-tempt tayo, damihan natin ng independent variables, lagyan lang natin ng 100 na independent variables. Kasi every time you add an independent variable, tataas yung R squared natin. Okay. However, guys, may cost yun, no? May cost. Kasi pag dagdag tayo ng dagdag ng independent variables, bababa yung degree of freedom natin. Okay? And pinapenalize tayo for this measure, adjusted R squared. Okay, so the higher the, if you keep on adding variables, you'll get a higher R squared. However, we will be penalized for that kasi baka independent variable na dinadagdag natin, wala naman siya nako-contribute para i-explain yung dependent variable natin. No? So that's why we have this measure, adjusted R squared. So kapag multiple regression, guys, mas ginagamit si adjusted R squared kaysa kay kay R squared. No? Okay, let's take a look at this. FSTAT. So ito, madali ma-compute to. No? Ang gusto kong explain ito, 1 at saka itong 524. Okay, so yung una dito, so let me write it here. Yung una, df is equal to 1 is equal to, that's your k, equal to number of predictors. No? Tapos yung df2, that's your number of observations, which is your n, minus your k minus 1. Alright, so tingnan lang natin, degree of freedom daw natin, dalawa, 1 and 524. Saan ang galing yan? So si 1, guys, is the number of predictors, yung k natin. Or others call this q. Okay, so ilan ba yung k natin? Ilan yung q natin? Isa lang, si education. So how do we now compute for the degree of freedom 2? It's n minus k minus 1. Ano yung n natin? N natin is 526. Okay? So minus 1, which is your k, and then minus 1. Bakit may minus 1 pa? This will account for your intercept. Kasi dito sa predictors, hindi naman natin binilang si intercept dyan eh. However, since kinukompute pa rin natin si intercept, guys, so mababawasan pa rin tayo ng isang degree of freedom. Kaya that's why it's n minus k minus 1. So 526 minus 1 minus 1, that's 524. Okay? And the p-value is 2.0.000, etc. 2.2. No? So halos pareho lang nitong p-value dito. Okay. So may p-value na naman tayo dito, may f-stat na naman tayo dito. So ibig sabihin may inference na naman tayo dyan. Okay? By the way, ito, ang tawag dito sa statistical test na to, okay? T-test yan, no? So that's what we call, tawag natin doon, individual T-test of the coefficients. Yung beta null natin, beta 1. No? Okay, so that's your individual T-test. Tapos meron naman tayong isa pang test, ito. So dito sa model natin, dito sa output natin, dalawang test. No? Ito, we call this the goodness, okay, overall goodness of fit test. Okay, so yung result na f-stat, at saka itong p-value dito, this is for the goodness of fit test. Okay, so since may test yan, may hypothesis tayo yan. Ang hypothesis natin yan is B null is equal to B1 is equal to 0. Okay, so iba to kaysa dun sa individual t-test. No? Ito, f-test to, tapos overall goodness of fit. So lahat ng variables, ini-equate natin to 0. And then since P is less than 0.05, ang conclusion natin is we reject the null hypothesis that all the parameters, all the coefficients are all equal to 0 because the p-value is less than 0.05. There's strong reason to believe that at least one, no? At least one of this. Hindi natin sinasabing lahat zero yan, no? At least one of the parameters is not equal to zero. So sa overall goodness of fit test, ang test natin dyan, lahat ng variables is equal to zero. Ang conclusion natin, either we reject, pag re-reject natin to, ibig sabihin, ang conclusion natin, at least one of these is not equal to zero. Or if we fail to reject, ang sinasabi natin, na lahat ng mga parameters natin, beta null, beta 1, kung may B2, B3, B4 pa, lahat yan equal to zero. Okay, let me pause for a while, guys. Any questions? Clear ba? Clear? Okay, thank you. Yung iba, guys, ano naman kasi we're actually medyo running out of time, no? Okay, so ito sinulat ko na kanina to, guys, no? Ito yung equation. Hindi ko lang alam. Nagra-run ba sa inyo? Nagkakaroon ako ng math processing error eh. Dapat lalabas yung equation dito. Ayun yun lumabas. Okay, so ito yung equation natin, no? Hourly wage is equal to negative 9.049 plus 0.554 times education plus epsilon sub I. So epsilon sub I, ibig sabihin error term yan, no? Okay? Kung papalitan natin yung value ng education, so gagawin natin computed, lalagyan natin to ng hat, no? Saka matatanggal yung epsilon sub I. Alright. So ituloy natin. So you can actually compute for r squared, although pinakita na kanina. So di ba ito yung 0.1648, no? So this is the coefficient of determination. This means that 16.48% of the variability of your dependent variable hourly wage can be explained by your model, which is si education, no? Si education lang kasi yung predictor natin. Okay. Now, itong r squared na to, guys, kailangan natin maintindihan kung paano ma-compute yan. Paano kayo compute? In order for us to compute that, kailangan natin makuha itong ano. Ano pa processing error ako eh. Sa inyo, guys, lumalabas naman ano. Ayan, okay, lumabas na. All right. So we look at the tatlong measures, SST, SSR, and SSE. Residual, dapat ito, we call this SSE. Ito, dolinagay na natin, SST. Okay, first, SST, no? Sum of the squares over total. Now, anong ginagawa natin dito? Si hourly wage, ima-minus natin sa average na hourly wage, no? Hourly wage minus average ni hourly wage. And then isa-sum up natin. So i-perform nga natin to. Okay, let me copy this. Okay, copy natin yung ito siya, no? Copyin ko lang to. Control C, dito ko na lang i-copy. Control V. So this is your hourly wage, no? Minus the average of hourly wage. Ito alam natin to na average is, diba alam natin yan eh. Ayaw niya. Okay. Ayaw. All right. So let's sum this up. So what happens here, guys, is that yung hourly wage natin, ima-minus natin sa average. So parang ito yan, no? Hourly wage minus average is 5.9. Minus 5.9, minus 5.9. Bawat isa dito, ima-minus sa 5.9. Tapos isa-sum up natin. And what do you get? So kulang pa ng isang parenthesis. Okay. So it's practically zero, guys, no? 0.00000, 12 decimal places, and then 185. So that's practically zero. So anong sinasabi natin dito? Na yung difference ng hourly wage dun sa average niya, pag sinum up natin yun, zero yun. Because that's what the definition of the mean is. That's what the definition of the average is. Yung average is that point, nasa central tendencies niya, na kapag minus natin, bawat points doon, minus natin bawat points doon, and then isum up natin, we'll get zero. Excuse me, guys. Sorry. Okay, so that's why we don't do that, no? Ang ginagawa natin, guys, kinukuha natin yung difference, okay? Wide hat. Ito, mean, no? Mean, tapos ini-square natin. So yung difference ng bawat points dun sa average niya, and then square that, that's what we call your SST, sum of the squares total. Ano ba meaning nito? Ang ibig sabihin nito, guys, we're not using any other variable to try to describe your hourly wage. Hindi natin ginamit si X dito, no? Diba? So we're saying here that if we don't have any other predictors, kunyari, wala tayong value ni education, wala tayong value ng ibang X, ng ibang independent variables. And if we're being asked to model your hourly wage, the only thing that we can do is get the average of hourly wage. Okay? So ito yung difference ng bawat value ng dependent variable natin sa average niya. And then in-square natin and then sinum up natin. Okay? So that's your SST. Then what happened here? I'll start with SSR. So si SSR, sum of the squares of your regression. Ang ginawa natin dito, guys, nag-regression tayo. Okay? Nag-model tayo, yung kanina, and that's your predicted value. Okay? So bawat ano natin, if we know the we can predict each of your hourly wage if we know education. Okay, going back here. Okay, di ba ito lahat may education values to? We can now have a prediction for your hourly wage based on education, no? Kasi di ba hourly wage is equal to negative 9.09 plus 0.51 times education. Ay, sandali, inom muna ako na sandali. Okay? Sorry about that. So, guys, naintindihan nyo yung sinasabi natin? Kasi di ba may model tayo? Okay, ito yung model natin, di ba? Asan yung model natin? Ito, di ba? Ito. Negative 9.049. Mape-predict natin si hourly wage if we know education. Okay, so bawat education dito sa data natin, okay, ito, pag re-replace natin si 11, may makukuha tayong predicted value ni hourly wage. And the predicted value is your model value. Iba siya dun sa actual value. Pag sinabtract natin si actual value dun sa predicted value, magkakaroon tayo ng residual. Kasi magkaiba sila. Kung magkaiba sila, no? Okay? Pause muna ako, guys. You get that? Nakuha ba? Paki-chat nga kasi I don't want to continue if we clear. Clear ba so far? Okay. Thank you. The rest? Okay. Walang questions? Okay, kung may questions guys, chat lang ha. Okay, so kailangan natin ma-compute yung SST, SSE, and SSR. No? Madali lang ma-compute yan based on the formula. So, ito, no? Sandali. Si SSE, guys, this is the sum of the squares of your errors. Yung iba, ang tawag dito, SSR, sum of the squares of the residuals. So medyo iba-iba yung ano natin, iba-iba yung paggamit ng iba't ibang authors. For us, gagamitin natin sum of the squares of your regression, SSR, sum of the squares of your error terms, residuals. Okay? So, ano to? Ano yung squared values ito? This is your actual value minus your predicted value. So kunin lang natin yung difference ni actual minus the predicted, square natin, i-add natin. Yun ang SSE natin, errors natin. Ito naman guys, SSR will be this is your predicted minus the mean. Okay, ano nangyari dito? From the mean guys, gumawa tayo ng, ginamit natin si X, si education. So nagkaroon tayo ng panibagong values. Instead of just using 5.9, meron tayong iba't ibang values for our hourly wage. So yung difference yan, ibig sabihin, yan yung improvement ng ano natin. Yan yung improvement ng prediction natin. Yun yung na-explain natin sa data natin. Instead of just using the mean, since gumamit tayo ng X variable, nakapag-model tayo, okay? So, using regression, so we were able to improve on the initial on the SST. Yung initial natin na ang ginamit lang natin si average. Okay? So let's run this. Run natin to. SST, SSR, SSE. And then you will find out that SSR plus SSE is just equal to SST. And that RSQ, yung R squared natin, is simply your SSR divided by SST. So let's run this all together. Run. Okay. Bilis ng oras. Ako, tatapos tayo. Okay. So SST. Ano yung SST? Sum of the squares of total. Ito yung total variability. Total variation ng HR wage natin. Okay? Kinuha natin yung difference ng actual minus the mean. In-square natin siya. Sinum up natin siya. So this sum of the squares. Kaya nga, sum of the squares. Total. Tapos ano nangyari guys? Si SSR, ito yung regression natin. Sum of the squares of your regression. Ano nangyari? Na-improve natin yung ano natin, yung model natin. Kaya nga ito guys, sum of your fitted, no? Ano yung fitted? Fitted guys is the function for predicted value. So you can use this function fitted and fitted ng model 1, no? So yung fitted value ng model 1 are your predicted values. Okay, so your predicted values minus the average ng wage, hourly wage, di ba? Yung difference na to, tapos in-square natin, and then sinum up natin, that's your sum of the squares of your regression. And it's 1179. Ibig sabihin, out of the total variation na 7160, ang na-explain natin 1179 because we used education as a predictor. Therefore, yung error pa, yung residual, yung hindi natin na-explain, 5980. Ito yung formula na yun, no? Fitted minus the actual value. Okay? And then, ito guys, SST, pag sinum up natin si SSR at saka SSE, okay, so SSR plus SSE, itong dalawang to, it's the same as your SST. Okay, therefore guys, alam natin na SSR plus SSE will total your SST. And then if we get the ratio, yung regression natin, yun na-explain natin, divided by the total variability, so it gives us 16.48. So that's your R squared, no? So ibig sabihin, yung kayang i-explain ng variation ng dependent variable natin, okay, it's 16.8%. Okay, kasi ito yung regression natin, no? SSR. Okay? Which is just the same as your yung ginawa natin kanina summary. Okay, any questions guys? Allah. Okay. Sorry, I need to continue guys, no? Okay, so ito, JTools just gives us another good output, guys, ito. So nakita nito magandang tabular output to, no? observations, dependent variable natin, OLS. Ito yung degree of freedom 1, degree of freedom 2, ito yung F statistic natin, ito yung p-value natin, R squared, adjusted R squared, and then ito yung mga parameters natin dun sa independent t-test natin for our coefficients. Okay, so that's just another way to generate your OLS. Now, ito, yung mod 1 natin, maraming laman yan, no? So number 1, names ng model. Ito yung laman ng model 1 natin, guys, no? This is our mod 1. My coefficients, my rank, my QR, my call. So it's a list of several objects, no, inside. So hindi lang siya yung parang table kanina, maraming laman yan. It's a list actually. Now, take note also that the way to report your... Okay, may mali ako dito, no? So, sorry, tanggalin ko to. At ko ba linagyan ng dollar yan? Okay. Okay, so I would that you read this, guys. Okay, tingnan nyo lang, basahin nyo to, and then we'll go back to this next meeting. I just want to show you ito. Okay, so i-plot natin tong lahat na to. So this is just the same plot. Kanina naglagay lang tayo dito ng ano, no, ng alpha, ng transparency. Tapos para magamit natin tong alpha, dapat i-define natin yung color, no? Color is equal to red, green, blue. Red, green, blue. 0, 0, 0 na red, green, blue. Black yan. Black, no? Tapos main. Tapos again, tapos naglagay tayo dito ng segments, no? So let's just quickly run this. Okay. So makikita natin dito, guys, yung mga segments natin dito, tingnan nyo, yung mga red lines na yan. Yun yung mga residuals natin, no? Yun yung mga distance ng mga points natin to the regression line. Okay? Kuha nyo, guys, yung mga red lines na yan. That's the distance from the regression line. So here we're drawing the error terms, no? The error terms. And explain ko next meeting kung paano nakukuha yung the method is called OLS, ordinary least squares. Okay, so okay, ito last two na to, guys, no? So we can access the residuals and the predicted values of your of model 1 natin. So here we're creating two objects, res at saka pred, okay, which consists of the residuals and the fitted values. So dito makikita natin pareho yan. Ito yung residuals natin. Tapos sa baba, yung isa pa, ito yung mga fitted values natin. Okay, ito yung mga predicted values natin. Okay, then lastly, okay, let's stop here in this function here. Here. Okay, so nag-create tayo ng object na mod1 diagnometrics. Let's access that. Ano ba laman ng object na yan? Ito. Yung augment function will add. Okay, so ito yung dependent variable natin, HR, wage, education, independent variable. Ito yung mga predicted values natin from the model. Ito yung mga residuals. Okay, so how did we get this? For example, 3.10 minus 5.05. So difference siya ng actual at saka ng predicted value. Tapos ito, ni-normalize lang to. In-standardize lang. No? And then we have Cook's distance. No? Si Cook's distance, guys, ginagamit yan to determine kung influential yung point na yun. No? Influential tong point na to. Okay, so we'll continue with this next time, guys. May I request you to please go over. Okay, tuloy nyo lang, guys. Pakituloy lang, sorry, ito. Pakituloy lang na basahin to. Okay, and then pakirun nyo na kasi andyan na naman yung code eh. And then try to see kung ano yung binibigay nito. No? Okay, so next meeting, tapusin natin to plus the continuation of this. And then for Friday, the last lecture, and that will be all. Okay, so thank you so much, guys. Thank you so much for your patience. And keep safe, all. Okay, mag-a-announce pala ako, guys, anong take, naku, hindi ko na-discuss, sorry, yung take home, yung online quiz natin this week, no? Wala pa tayong nag-agree na date. Mag-aano lang ako, magpo-post, no? Okay, sige. Thank you. May magpapacheck ba ng attendance?